Welcome back. If you have not seen the earlier videos, you should probably see the earlier videos before this one. In this video, I will be talking about the discussion section of a scientific report. At the end of this video, I'll also talk briefly about the title. So the title, of course, comes first. That's the first thing people see on your report, but it's in fact something that you should think about at the end after you've written your report. So we'll talk about that also in today's video. So, as I've mentioned in the other videos, there's a very typical organization for scientific papers. A very standard organization. It doesn't matter if it's a laboratory report or if it is a peer-reviewed article in an international journal. The basic structure is almost always the same. It starts with a title, then there'll be an abstract if it's a reasonably sized paper. If it's very short, like a laboratory report, you might not need it. So of course, check with your professor for a class to see if you need an abstract. Following that would be the introduction. And as I mentioned in an earlier video, that's best done as a literature review, followed by identifying what is it that you're trying to accomplish in the research or the experiment and what is your hypothesis. Then comes the materials and methods section, how the research was conducted. Following that, your results. And usually, particularly in a laboratory report, you'll have a table or a figure, maybe both, maybe a couple of figures. It depends on what it is that you're presenting. And then comes the discussion. And that's what I'll be focusing on in this video. After the discussion in your paper, if you cited anybody else's research, if you mentioned that Eno in 1998 published an article on blah, 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 well, there'll be a reference list listing all of these things that you cited in your report. Okay, so let me just do a little bit more by way of review. So what leads up to the discussion? Well, what leads up is, of course, the introductory section. So that introduction, that literature review. What is it for? It's supposed to give the reader background. So when it comes time to write your discussion section, you don't need to be giving background. That occurred in your introduction. If you come to the point where you're writing your discussion and you start thinking, oh, I should give this background information to my reader, then actually what you should go do is fix your introduction, because background information goes in the introduction. Then after the introduction comes the materials and methods. And as I've said before, that is basically the recipe for conducting the research, the recipe for conducting the experiment. So in the discussion section, you would probably give no information on how the research was done unless you need to remind the reader about something. So the original presentation of all of that information, how was the research done, that's in the method section. So you don't need to worry about that so much when you're writing the discussion, because you've already done it. It's in your method section. After the method section comes the results section. Now the results section, as I went over in the prior video, it contains in paragraph form, and that's very important, sentences and paragraphs, in paragraph form, all of the relevant results. And then these paragraphs might be supplemented with a figure, for example, to provide some other data that the reader might be interested in seeing, to show graphically what's going on with the findings, that sort of thing. And as I mentioned in the prior video, the results section, in fact the whole report, but in particular the results section, should be written absolutely objectively, no emotion. You measured this thing and you got this result, whatever it was. You don't get to show that you're happy or sad or upset or confused. You measured such and such, and you got this result. It's a very boring, neutral, objective presentation in the results section, which basically means, for many cases, it'll be lots of numbers. It'll be words mixed with numbers. Hence, there'll often be a figure to help make it a little bit more easy to understand. So if the results have already been presented in the results section, what's the purpose of the discussion? Okay, so the discussion section. Well, the overarching goal is to explain, what do the results mean? So you have these results, you have these numbers, you have a particular method you used, you have the measurements you took, maybe you have some equations and you calculated things, okay? What does it mean? What's the conclusion? So notice that results and conclusion are very different. Results are the things you measured and found with absolute certainty. Whether it was correct or not is a separate issue. With certainty, you measured something and it was 3.2 kilograms. Okay, it was 3.2. You're certain of that within the accuracy of your scale. But is that heavy? Is that light? Is that important? These types of things that are conclusions, that's what goes in the discussion. So your overarching goal is to explain what do the results mean. So if you were testing a hypothesis, and in lots of laboratory research, that's exactly what you're doing, but not always. But if you were testing hypotheses, you should clearly state, were your hypotheses supported, falsified, or it's less common, but you could be in one of these in-between kind of situations. But generally, you'll want to start your discussion section saying what your hypotheses were, just to remind the reader. It was hypothesized that, bum, 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 and this hypothesis was falsified, or this hypothesis was supported. And then start talking about the results that show that the hypothesis was falsified or that it was supported. So the discussion will give your conclusions, but it doesn't just list your conclusions. It gives the reasoning for your conclusions. Remember, the goal is that a naive reader, someone who has not taken the class, who's in a different major, who is not familiar with your experiments, except from having read your introduction, your method section, and your results. That's all they know. Based on that, you need to provide your reasoning for your conclusion. So you need to give the conclusion as well as the reasoning that leads to it, so they understand why you are drawing the conclusion that you are drawing. Okay? So very, very important. Don't just give your conclusions. Provide the rationale, provide the reasoning. Now, I said a lot about, or I've repeated many times, you should be objective. You should be objective throughout. You should be particularly objective in writing your results section. Well, is there any place in the paper where you can be a little less objective, a little bit of human emotion can go into it? The main place would be the discussion section. Now, this does not mean you should try to be subjective or to lack objectivity, but a discussion section is a much more human thing than the results section. The results section is much more about the numbers. It was measured, here was the number that showed up. Okay? Whereas the discussion is, what does it mean? What's the impact? What's the importance? What's the value of knowing these things? So you do not have to be quite as strict about objectivity when you're writing a discussion section, but try to be relatively objective even in the discussion section. What other things might you do in writing your discussion section? One of the things that can be really good and really helpful for your reader is to compare and contrast your findings with findings of other people who have done the same research. So when you did your introduction, hopefully you did a literature review. And in that literature review, you hopefully reviewed other people who did the findings from other people who did similar research. Well, you just did research. Did you get the same results? Or did you get something different? If you got the same result, you want to point that out. You want to compare. If you got something different, then you want to contrast and maybe speculate on why did you get a different result? How come two different experiments that both, it seems, would get the same results did not? So you want to compare and contrast your findings with other researchers and also think about and write about why might there be differences. Something else that does not pop into people's minds if they're not taught it usually is in the discussion section, you want to point out any limitations of the method that you used. And as a human, it's kind of not fun to do this. So there were all sorts of things went wrong during the experiment. You forgot something. You were supposed to time things and change something every 30 seconds. But you got distracted, and occasionally it was 45 seconds or a minute. And people are like, oh, maybe I just won't tell anyone. That's, of course, not appropriate in science. What you need to do is let the reader know things that went wrong, things that limited the generalizability of your findings, things that may have impacted the accuracy of your findings. So if things went wrong, you need to mention it. You need to mention that and explain how it may have affected the results. So pointing out limitations is very appropriate. And although people are often reluctant to do this, actually when scientists do this and other scientists read their work, these other scientists who are doing the reading, they're impressed. It makes a very good impression. Ah, this person is honest. This person I can trust. So it's actually a very good thing to do. So think about your design. Is there some aspect of the design of your experiments that inherently creates a limitation? If so, talk about it. If there's 2 of them, talk about both of them. If there's 3, talk about all 3. Okay? And the other thing, which I sort of already mentioned, is what about an unexpected occurrence during the experiment? So you were supposed to measure something every 30 seconds, but in fact it was 45 seconds or a minute on some occasions. These things that were unexpected, not planned for, happened. It's real life. So think about, what are the limitations due to the design? What are the limitations due to what actually happened? And discuss all of these. So you might have 1 paragraph, you might have 5 paragraphs on this in your laboratory report, depending on what you did and what happened. So in your discussion section, as I said, it's a little bit more human than the results section. So you are expected to present and discuss your opinions and your thoughts on the findings. Now, not wild speculations, okay, but given the method you used, given the results that were obtained, what does it mean? What do you think about it? What are the implications? What did you learn from it? For a laboratory report, your professor might be looking to see, what did you learn from it? So you might want to make sure you include what you learned from it. So why are your findings important? What was gained or could have been gained by doing the research? Another one is, are your findings important? Now, in a laboratory situation, probably it's something that's been done hundreds of times by hundreds of people, so you're unlikely to have cured cancer or something significant like that. But if you found something really important, it is appropriate to say so. Some people are like, oh, have to be very modest and hold back. But in fact, if you found something important, it's perfectly fine to say so, but you must explain why. Give your conclusion, but provide your reasoning. One other thing you might want to do, and this is, some people do this because they think that they're supposed to. So for example, if you're writing a business letter, you usually say, "Dear," and the person's name. And at the end of the business letter, you might write something like, "Sincerely," comma, and then sign your name. There's this sort of formula for how you do things. Some people think that as a formula, at the end of a scientific report, you should state what research should come next. Now, in fact, if you're going to do it as a formula, my recommendation is, do not do it. That's just a waste of your reader's time, and it looks like you're just following a formula rather than writing a real report. However, you just did research. You have looked at your results. You're writing the discussion section. You have written your conclusions, your reasoning for your conclusions. You are in an excellent position to make a recommendation to the reader who might want to do this kind of research. So imagine that somebody has just read your report, or they're reading your report, and they're thinking about doing the research. Maybe you can make a suggestion as to how they could do it better. What went wrong during your research that if you told the reader about it, they could design their research so that problem would not occur? So think about what research should come next, what would make an improvement to the research, and then give that information to your reader as your closing. That can be a very nice closing to a scientific paper or a laboratory report. Let's go over a few miscellaneous things to think about, particularly when writing your discussion section. In terms of verbs, what tense should you use? Well, it completely depends on what you're writing. So when you're summarizing what was done, well, it was what was done. It's past, so it'll be past tense. What about for limitations that occurred? Well, limitations that occurred, again, they occurred in the past, so you're probably doing past, maybe past perfect for emphasizing what happened there. But that doesn't mean you won't be using present or future tenses, because in the discussion, you may be generalizing your findings, saying that this is generally true. Well, that's a present tense thing. You may be talking about future research. That's a future thing. So present and future tenses both would appear in a discussion section. So there'll actually be a wide range of tenses that are used in most discussion sections. So basically, you need to look at exactly what is it that you're presenting, and then use the appropriate tense. I've mentioned this one before. It applies to all scientific writing in English, all modern scientific writing in English, and that is, you are not supposed to use I to refer to yourself, or we to refer to you and your co-researchers. You're not supposed to use you to refer to the reader. So these types of words should not be there. So if you find yourself using them, because it's very natural to use them in English, and it's even natural to use them in written English that's not for science. But in scientific written English, you should not be using I, we, you, my, our, your, these types of words. So switch to passive voice. And if passive voice does not work for some reason, then say the present authors or the present investigators or the present researchers. Use this type of wording to refer to yourself. Also, as I've mentioned a few times, if you mention anybody else's report, their talk, their book, their article, then you need to provide the citation in the text, but even more important, you need to have a reference list. So don't forget that you should cite anything that you refer to from somebody else. And of course, if you're taking a quotation from somebody else's work, that needs to be in double quotation marks, you need the page number, and of course, in your reference list, you need to include that work. What about tables and figures in a discussion section? Well, there is no rule that says you should not have tables or figures in a discussion section. However, in practice, it's very rare that you need them. So in the introduction, usually there would be no tables or figures. In the materials and methods section, there might be a diagram or a photograph showing the experimental setup. In the results section, very common to have a table, a figure, or multiple figures. But in the discussion section, what would be the new thing you're presenting? So usually there would be no figures or tables in a discussion section. It is possible to have something. For example, let's say after you do your research, you realize that there's a much better way to have done the research. And you're explaining to your reader, future research should, and you're explaining a new experimental setup. Well, if a diagram would help explain that, then you might put a diagram in your discussion section to support your explanation of an improved method for doing the research. But in general, you will not have tables or figures in your discussion section. But you will be talking about the findings. As a consequence, you might make use of the tables and the figures that appeared in the results section. And that's perfectly fine. You refer to them the same way. So in your discussion section, you might write, as can be seen in figure 3, the pattern of results shows that as the temperature increased, the reaction decreased. So you can repeat things that were from the results section, and you can refer back to the tables and figures that are in the results section. You do not need to create new ones. So it's perfectly fine to refer back to things that are earlier in your report. So that's what I wanted to say about the discussion section, but I want to continue a little bit more in this video and talk about the very, very first thing of a report, which is the title. So how should you write a title? What should go into a title? What should you think about in creating the title? Well, writing a title for a scientific report is very different than writing the title for, say, a book of fiction. Okay? So, Harry Potter and the Chamber of Secrets. Where is the chamber? What's in the chamber? Why is it secret? When you're trying to do something with fiction, you're trying to get the reader interested and wondering. But in science, we're supposed to be answering the questions. We're not supposed to be getting people wondering. We're supposed to get giving them answers. So in science, you want to give a very clear, very accurate title that provides information. So not that raises questions, but that answers questions. So when you design your title for your laboratory reports and for your scientific papers, think about how can you describe the findings. And a very long and descriptive title is perfectly fine. So again, if you're writing a fiction book, you might be The Green Door. 3 words, okay? And people are wondering, why is it green? Where is this door? What does it lead to? But that's a horrible title for a scientific report. So you don't need to restrict yourself to very short titles, and you should not be raising questions and sort of playing with your potential reader. So think about creating a longer, very descriptive title. The standard recommendation in science is aim for 10 to 12 words. Now, you don't have to have 10 words. If you can do a nice title in 5 words, then use 5. And you can go longer. I've gone up to as far as 20 myself in some of my publications. But many people do think a 20-word title is kind of on the long side. But think, if you have 5 words and you like the title, but a 10-word title would be more descriptive. Come up with a 10-word, more descriptive title. So you don't have to do 10 to 12, but that's the general neighborhood that's generally recommended. The goal is to explain to your reader or your potential reader via your title, what is the report about? So what is your report about? Another option is to think about, sometimes you think about your report and what you found, and it's really like 2 things you want to talk about. And how can you deal with that in the title? One possibility is to create a main title and a subtitle. And in English, we separate them with a full colon. So you write your main title, full colon, space, and then the subtitle. That's also fine. But in terms of thinking about length, you have to include both of those in your count. So maybe 15 words with a 8-word main title and a 7-word subtitle, for example, would also be fine. Something else to think about when you're writing your title is to avoid abbreviations, unless you are sure that in common English, in general English, not scientific, but in general English, it is a well-known, well-understood abbreviation. Because remember, the goal is to provide accurate, descriptive information in just a few words. If there's an abbreviation and a potential reader doesn't know the abbreviation, they'll be confused. The goal is not to confuse them. The goal is to tell them what is your report about. So because of that, never use abbreviations unless they're really well known. So like DNA, okay, probably almost everybody who graduated from junior high school will know what DNA is. You can use DNA in a title. HIV, back in the 1980s, you could not use that. Not enough people knew what it was. Today, it's reasonably common, so you could probably use that in a title. So think about, how well known in general English is an abbreviation. And if it's well known, go ahead and use it. If it's not, then write out the actual words instead. As I keep saying, your main goal with the title is to let your reader know quickly and easily what's the report about. So you can either do that by focusing on the topic or on your finding. So for example, if you found something interesting, your main finding was rather interesting, you might think about using that as a title, just telling the reader what you found in 10 to 12 words as a title. But regardless of which approach you use, what the report is about versus what the report found, you want to convey to the reader very clearly, very accurately, what the report's about, so that they can decide, oh, I do want to read this one, or I do not want to read this one, and that's okay too. So just a few thoughts about writing the title. So I hope this video helped you out, and I hope the other videos help you as well. Thank you for watching.